Hi guys, welcome back. So today we're going to talk about significant figures, and this is actually a pretty quick one to go through. I think your textbook makes it so much more complicated than what it actually is, so I'm going to move through this pretty speedy today. Okay, so significant figures. Let's start off with what significant figures actually are. So they're the number of numerical figures that can be used to express a measured or calculated quantity. And your textbook has like 5 rules or something for significant figures. It just seems like it's getting too crazy. Okay, so a significant figure is basically just a figure that cannot be used as a placeholder, or is not being used as a placeholder. So what do I mean by that? Well, let's say I have a really, really tiny number, so 0.000125. Now, all of these zeros here, these are just being used as place values. So if I was to write this in scientific notation, I would have my leading digit here 1, and then I would have my following digits, and then I've moved this decimal 1, 2, 3, 4 spots. So this would be times by 10 to the negative 4. And I hope that you can appreciate, now that I've written this in scientific notation, that this number here only has 3 significant figures. If I was to change this, so if I was to have, say, 0.0205, for example, this 0 is no longer being used as a placeholder, because if I was to write this using scientific notation, I would write this as 2.05 times by 10 to the power of negative 2. And so I hope that you can see here, this one will also have 3 significant figures as well, because these zeros are just being used as placeholders. Now, going the other way, let's do a large number. So if I had 250,000, again, these zeros here, I'm assuming are just going to be placeholders. If I was going to write this using scientific notation, I would write this as 2.5 times by 10 to the power of 1, 2, 3, 4, 5. And so this would actually only have 2 significant figures. So when we're using significant figures, what we should do is, first of all, if we are going to be adding or subtracting, so if I'm adding or subtracting some significant figures, let's pick some simple numbers. So if I did like 2.45, so this has 3 significant figures in total, but 2 of them are after the decimal place. And I was going to add that to 1.2. I would still calculate that value as per normal. So this would be 3.65. And since we're adding and subtracting, what we're going to do is we're going to look at the number with the least number of significant figures after the decimal place. So for this case, the least number of significant figures is just 1 significant figure. So I would actually write this as 3.7. If we were to multiply or to divide some numbers, so let's take a simple example. If I did 3.2 times by 1.15, and I worked out the value for that, I'm going to get 3.68 as my value. And so for this one, rather than looking at the numbers after the decimal place when we're multiplying or dividing, we just look at the total numbers of significant figures. So this one here, the least number of significant figures would be 2, so we would write that as 3.7 again. Okay, so let's go through and do some examples here. So identify the number of significant figures in 0.4507. Now this 0 is not being used as a placeholder, so this would have 4 significant figures. Now, these 2 zeros here, I'm assuming that they've actually measured those 2 zeros, because why would you bother including those 2 decimal points if you had not measured to that degree of certainty? I mean, it could be used as a placeholder, but I think that they've actually gone ahead and measured to that point. And this is different from our example that we used before with the 250,000, because if we were to rewrite this using scientific notation, we would have just done 2.5 times by 10 to the 4, was it? No, 10 to the 5, I should say. Whereas with this one, 123.00, because this is after the decimal, I'm assuming we've measured to that point. So if I was to write this in scientific notation now, I would write it like this. So this would actually have 5 significant figures. This one here is only going to have 2 significant figures because these are placeholders, and this would also only have 2 significant figures because the 10 to the power of negative 3, again, is just indicating that those zeros will be placeholders. Okay, apply your knowledge of significant figures to rewrite the following correct to 2 significant figures. Okay, so for this one, it's going to be 3.5 because we need to round this one up so that we have 2 digits. Now for this one here, this is a little bit trickier. So I want these first 2 leading digits only. So I'm going to round this up. So this is going to be 360. Or in other words, I could write this as 3.6 times by 10 to the power of 2. So that would be the number of significant figures because this 0 is now just being used as a placeholder. Okay, 305. So again, we just want to go to 2 significant figures. So I'm going to look at those first 2 leading digits. I'm going to have to round. So this is going to be 310. And again, this 0 is now just being used as a placeholder. So if I was to write this with with scientific notation, I would write this as 3.1 by 10 to the power of 2. And so that would be correct to 2 significant figures. Ooh, and lastly, our favorite, what number is this number? Comment down below if you know what this number is in reference to. Writing this to 2 significant figures, I'm going to look, so that would be my first 2 leading digits there. I would then round, so then I get 6.0 times by 10 to the 23. And see how this time we still write the 0, but we must have measured it to this point because there's no point including zeros after the decimal point if you haven't measured to that point. And so this would contain 2 significant figures now. Again, your textbook has like 5 rules and it just seems very complicated. Just think about, is this 0 a placeholder or is it not a placeholder? Have I actually measured it to be exactly 0.00 of a gram or whatever? Or is it just that I'm just chucking those zeros in because I think it'll make my assignment look better? I think we know the answer. Okay, so apply your knowledge of significant figures to determine the following to the correct number of significant figures. So I'm just going to clear off some space here and then let's go through and do this question. So remember when we are adding or subtracting, we're going to look at the digits after the decimal place. So we'll have 0.0426 minus 0.002. And all these zeros here you can tell are just placeholders, same with these zeros here. So this one has 3 significant figures and this one only has 1 significant figure after the decimal. And so we should only do this to 1 significant figure. So my solution is going to be 0.0406. By the way, we should always do the calculation first and then do the rounding at the end, because if we round at the beginning, we're going to have a whole bunch of error and we don't like to have that. So we only ever round as we get to the very end of our solution. Okay, so we want 1 significant figure, so we're just going to round that, and that's going to be 0.04 for our solution. Apologies. Let's try this now with question B. So this is multiplication or division. So with this one, we are not looking at the numbers after the decimal place. We're going to look at all of the numbers. So we've got 2.45 times by 3.0. And because this is a decimal, I'm assuming I would have measured 2.0 because if I wasn't sure about it, I would have just written that as 3. So 2.45 times by 3, this has got 3 significant figures. This has 2 significant figures, so my solution should have 2 significant figures as well. So if I pop that into my calculator, I'm going to get 7.35, and I'm going to round that to 7.4, again, doing the rounding at the end. Okay, so you guys can have a go now at this question 6. So a student calculated the density of an object with a mass of 4.525 grams and a volume of 3.0 mils, correct to 1 significant figure. Okay, so the answer was 1.508 grams per milliliter. Identify the errors in this answer, include the correct answer in your explanation. Now, just think too what's going on with density. So density is the amount of mass per particular volume, and this is in grams per litre. So this is a division. So think about how we would have to do that problem using our rules for division. Alrighty guys, if you've got any questions about that, please do let me know, and I will see you next time. Bye guys.